Welcome back, everybody, for another deep dive. This time, we're going to be tackling a really fascinating topic, the evolution of the human brain.
Yeah.
But not just the typical, how it grew bigger over time kind of story.
Right.
We're looking at it from a really unique angle presented in our source material.
Absolutely, yeah.
And that's how this idea of the size range might actually be connected to our very ability to understand the world around us,
Yeah.
our place in it, and maybe even what reality itself is.
It's a huge question, right?
Yeah.
I mean, it's something that humans have been grappling with for millennia.
Totally.
Why are we so obsessed with figuring things out? Why are we so driven to find meaning?
It's like we're hardwired for it.
Yeah.
You know?
Where does all that come from?
Yeah. And what I find so fascinating is that our source material actually suggests a link between the development of thought itself,
Okay.
the concept of God,
Right.
and the structure of reality, and all of it kind of coming back to this idea of the sizer range.
So I guess maybe we should start with, what do we even mean by the sizer range?
Right. Let's break it down.
When we talk about the size range, we're really talking about the entire spectrum of existence, from, the infinitely small to the infinitely large.
So we're talking tiny particles to massive galaxies, all within this concept.
Exactly. Everything that exists fits somewhere on that spectrum, right? And our source material makes a really interesting case for why this size range, it has to be infinite.
Okay, infinite size range. I'm listening. How do they get to that?
Well, one way they illustrate it is through this idea of justification.
Okay.
Basically, each size in the size range is justified or explained by its relationship to the sizes above and below it.
So smaller things combine to make bigger things, and those bigger things provide the context for the smaller ones.
Yeah, precisely. So, if you keep going in either direction, if this chain of justification continues infinitely, then it suggests that the size range itself, it must be infinite.
Okay, my mind is already kind of bent,
Yeah.
thinking about an infinite size range.
It's a big concept.
But how does this idea connect to our brains? How did we get here?
Well, our source material proposes this fascinating idea that evolution itself might actually be a product of the size range.
Right.
That instead of thinking of the size range as something that we discovered, maybe it's actually the very framework that allowed for the development of, complex brains capable of understanding it in the first place.
So instead of it being a result of our understanding, it's the foundation for it.
Yeah, that's the idea. And to see how this might have played out, let's go back to one of the most foundational thinkers on the nature of reality.
Okay.
René Descartes.
Oh, Descartes.
His famous declaration, "I think, therefore I am," might actually hold a key to understanding how our brains evolved to make sense of everything.
Oh, okay. See, I remember studying Descartes in school, but I got to be honest, a lot of it went right over my head.
Yeah.
So can you break this down? What was he really getting at?
So Descartes was obsessed with this idea of finding a fundamental truth, something he could be absolutely certain of.
Okay.
And he realized that even if some all-powerful demon was trying to deceive him about, literally everything, the very act of being deceived, the act of thinking, proved that he, the thinker, had to exist.
So even if reality was an illusion, the fact that he was experiencing it meant he was real.
Exactly, yeah. And what's important for our conversation here is that Descartes realized that for deception to even exist, there has to be this distinction, this separation between the deceiver and the deceived, the thinker and the thought.
It seems like a pretty simple idea, but you're saying this concept of distinction, it's crucial to understanding reality itself.
Absolutely, yeah. To perceive anything, to understand anything, our brains, they rely on making distinctions, separating objects, identifying differences, categorizing information.
Okay, so distinction is key. But our source material takes it a step further with this idea of anti-distinction.
Yes. This is where things get really, really interesting.
Okay, lay it on me. What is anti-distinction?
Anti-distinction is the opposite of distinction. It's the idea of a singular, unified reality where everything is interconnected.
Mm-hmm.
It's like trying to visualize the entire universe, everything, as one single indivisible whole.
That's a lot. I mean, we're so used to seeing things as separate, as distinct. It's hard to wrap my head around that.
It is a challenge. It's a really big challenge. One of our sources uses this great thought experiment to kind of illustrate this. Imagine trying to visually represent reality on a piece of paper.
Okay.
No matter how you do it, right? You inevitably end up with distinct elements. The thinker, the thought, the space between them.
I see what you mean.
It highlights how difficult it is for our, distinction-based brains to actually grasp this idea of a truly unified whole.
Yeah, so even when we try to picture that ultimate oneness, we're still trapped by our need to separate and categorize.
In a way, yeah. And this tension, this struggle between distinction and anti-distinction might actually be at the very core of how our brains evolved to understand both the world around us and the vastness of reality itself.
Okay, now I'm really intrigued.
Yeah.
So how does this all tie back to the size range and evolution?
Well, next, I think we need to dive into how the source material explores the very beginnings of life itself, like those first reproducing organisms, and how that drive for survival within the context of this infinite size range might have set the stage for everything that followed.
Okay, I'm ready. Let's dive in.
All right. Okay, so we've kind of laid out this idea of the infinite size range, right? The spectrum of existence from the super tiny to the unimaginably huge.
Yeah, we're talking everything that exists fitting somewhere on that line.
Exactly. And now let's kind of zoom in way into the very beginnings of life, those first self-replicating molecules.
So like picture that primordial soup teeming with those tiny building blocks of life.
Right. And the source material highlights those classic rules of evolution that were at play, right? Survival, number of offspring, mutation.
Like evolution 101, right?
Yeah, exactly. But then it adds this really fascinating layer by proposing that those rules themselves, they might actually be expressions of the size range.
Okay, now that's interesting. How do those rules connect to this whole size range concept?
Well, imagine those early life forms constantly replicating, competing for resources within this vast, possibly infinite size range. Their survival depended on their ability to navigate it, to find their niche, to exploit the opportunities it presented.
So the size range itself becomes a kind of a selective pressure, shaping which organisms thrive and which ones, don't make it.
Yeah, exactly. And as they're replicating, right, their success is measured by the number of offspring they produce.
Okay.
Which is, again, another rule that can be seen as a reflection of the size range in a way.
I mean, yeah, the more offspring, the more they can spread out and occupy different niches within that size range.
Precisely. And then, of course, you have mutation, that random element of change that introduces these variations into the population.
Right, that wild card.
Yeah, and those mutations that better equipped those organisms to navigate the size range, to exploit its resources, to overcome its challenges, well, those were the ones that were more likely to get passed on.
So it's almost like the size range acts as a filter, selecting for those traits that are most advantageous within its structure.
Yeah, that's a great way to put it.
Okay.
Now, as life became more complex, this interaction with the size range also shaped the development of new strategies, new ways of competing, new ways of surviving. And our source material points to this emergence of something beyond those basic rules, this drive for power.
Okay, power. I mean, we usually think of power in terms of like, physical strength or social status, but how does that even apply to these early life forms?
Well, think about viruses.
Okay.
They're incredibly simple organisms, right? But they've evolved this remarkable strategy for survival, hijacking the reproductive machinery of other cells.
So they're not just like competing for resources, they're actively manipulating other organisms to benefit themselves.
Yeah, exactly. It's a clear example of how this drive for power, this drive for control over the size range can emerge, even at the most basic levels of life.
Like tiny little genetic pirates, commandeering the resources of others for their own replication.
Yeah, that's a great analogy. And this viral strategy, this drive to exert influence over the size range actually spurred some pretty major evolutionary leaps.
Okay, like what?
Well, for instance, think about the development of the immune system.
Right, yeah.
That was a direct response to the threat of these viral hijackers.
So our bodies develop defenses to protect themselves from those who are trying to manipulate the size range for their own benefit.
Precisely. The immune system with its complex mechanisms for recognizing and neutralizing threats, that can be seen as a product of this ongoing arms race for control over the size range.
So it's not just about, fighting off disease, it's about maintaining control over our own biological processes within this vast interconnected web of life.
Absolutely, yeah. And this interplay between power and the size range, it continued to shape evolution as organisms became more and more complex. In fact, our source materials suggest that this drive for power even played a crucial role in the development of multicellular life.
Okay, now how did that work? I mean, I'm having a hard time picturing how single-celled organisms made that leap to become multicellular.
Well, imagine a scenario where a group of cells, instead of competing as individuals, they start to cooperate. They start pooling their resources. They start specializing in different tasks.
Okay.
This would give them a significant advantage in the struggle for survival, right?
So it's like those cells realized that working together gave them more power within the size range than going it alone.
Yeah, exactly. And this cooperation, this formation of multicellular organisms, it opened up a whole new realm of possibilities. It allowed for the development of tissues, organs, complex body plans, all driven by this underlying drive to control, to manipulate the size range.
So from those very first self-replicating molecules to complex multicellular organisms, it's like this size range concept has been shaping evolution like every step of the way.
Exactly. And this brings us to another fascinating example of how this drive for power played out. The evolution of male aggression in fish.
Okay, I'm intrigued. What do fish have to do with this grand narrative of the size range and evolution?
Well, our source material points out that in many fish species, males exhibit this aggressive behavior, right?
Yeah.
They're competing for territory, they're competing for access to females. This aggression, while it seems destructive, it can be seen as another expression of this drive for power within the size range.
So by controlling territory and access to mates, those aggressive males they're essentially securing a larger portion of the size range for themselves and their offspring.
Exactly. And this drive to control resources, to maximize their influence within the size range, it's shaped the behavior and even the physical characteristics of so many species, including, our own primate ancestors.
Okay, this is where things start to get really interesting because now we're starting to see these connections between the size range concept and the development of the human brain.
Exactly. And that's where we'll pick up next time, exploring how this drive for power within the size range actually played a key role in shaping the evolution of our own brains and our unique capacity for understanding the world.
Okay, so we've gone from like single-celled organisms battling it out in the size range to complex life forms driven by this need for power.
Yeah.
I'm guessing this is where the human brain story really kicks into gear.
You got it. Our source material dives into how this drive for power, this competition for resources and influence within the size range actually played a huge role in shaping the evolution of our brains.
We often hear about how the human brain rapidly expanded in size,
Yeah.
especially in the last 100,000 years.
Right.
Was that all driven by this size range competition?
Our sources make a pretty compelling case for that. Think about the challenges our primate ancestors were facing. They weren't just competing for food and mates,
Right.
They were navigating these complex social hierarchies.
Well, it wasn't just about physical strength anymore. It was about social intelligence, like being able to outsmart your rivals, climb those social ladders.
Exactly. Those with larger brains capable of remembering those complex social interactions, predicting behavior, forming alliances, they had a real advantage.
Makes you wonder if all the office politics and social maneuvering we do today is just, echoes of those ancient survival instincts playing out in a modern setting.
It's a fascinating thought, isn't it? And the source material suggests that this intense social pressure cooker, it's what really fueled the rapid growth of the human brain, particularly the prefrontal cortex, the area responsible for, planning, decision-making, social cognition.
So our brains became these supercomputers, specifically adapted to surviving and thriving in these complex social worlds.
Right.
But where does the concept of God fit into all this? We've talked about size range, evolution, power, but haven't really touched on religion yet.
This is where things start to get really interesting, I think. Because remember, we talked about distinction and anti-distinction, this idea that our brains rely on making distinctions to understand the world, but there's also this inherent struggle to grasp that concept of a unified, interconnected reality.
Right. It's like we're trying to fit the entire ocean into a teacup.
Yeah.
Our brains crave those clear-cut categories,
Yeah.
but reality itself might be something far more complex and interconnected.
Exactly. And our source material proposes that the invention of God, particularly this idea of a single all-powerful deity, might be a direct consequence of this tension between distinction and anti-distinction.
Okay, but how does that work? How does the size range and our need to categorize, how does that lead to the concept of God?
Well, imagine those early humans, right?
Mhm.
Having developed this capacity for abstract thought, grappling with this concept of an infinite size range, this vast interconnected reality that defied their attempts to categorize it, to define it.
Like they hit the limits of their understanding, their ability to just break things down into neat little boxes.
Exactly. Yeah, faced with this overwhelming sense of oneness, this ultimate reality that defied their distinction-based brains, they might have personified that concept,
Yeah.
given it a name attributed to it, all those qualities that our brains crave,
Right.
power, knowledge, purpose.
So God became a way to represent the unrepresentable, to make sense of this ultimate interconnected reality that our brains just couldn't fully grasp.
That's the idea. It wasn't necessarily a conscious decision, but rather like an emergent property of how our brains, shaped by evolution within the size range, struggled to comprehend something so vast and all-encompassing.
It's a fascinating and somewhat humbling thought.
Yeah.
That something as fundamental to human culture as religion might have its roots in our cognitive limitations.
Yeah.
In our struggle to reconcile the world we perceive with the vastness of reality itself.
Yeah, it certainly challenges our assumptions about where our beliefs come from and how much our understanding of the world is shaped by the evolutionary forces that molded our brains in the first place.
Well, this deep dive has been quite a journey. We've gone from the building blocks of life to the vastness of the size range, explored the drive for power that shapes evolution, and even touched upon the origins of religion.
Yeah, it's a lot to take in.
There's a lot to process. But as always, the goal of these deep dives is to spark curiosity, to challenge assumptions, and hopefully to equip you with new ways of looking at the world and your place within it.
And I think we've definitely done that today.
I think so too. So for our listeners out there, here's something to ponder as you navigate the complexities of your own lives. If our brains are wired to seek power and make distinctions, to categorize and define, can we ever truly escape those limitations and experience the unity, the interconnectedness that might lie at the heart of reality?
Keep questioning, keep exploring, and keep pushing the boundaries of your understanding. That journey of discovery, it never ends. And who knows what mind-blowing insights await you within the vastness of the size range.
And on that note, we'll wrap up this
That's
deep
so
dive.
cool.
Until next time, keep exploring.